Hi there and welcome to lesson 2 in our C3 topic on chemical economics, and today we're going to be looking at rates of reaction again, rates of reaction 2, and we're going to be focusing on the factors that affect rates of reaction. Anyway, I will see you at the end of the lesson. Take care, bye. Okay, so here are our objectives for lesson 2, rates of reaction. So by the end of this lesson you should know and understand the factors that can affect the rate of a reaction. Okay, now there are a couple of things that we need to think about when we're looking at the factors that affect the rate of a reaction. Now, what we need to focus on really is what a reaction actually is. Now, when we have two particles in a reaction, what they may do is they may collide. Now, if we show these particles here, so they could be moving around, and this particle here can move and it might just bounce off each other. Okay, now that means they've had a collision, but it's not been successful. Now, what could happen is that we could have the particles moving towards each other, and then we get a successful collision, and they've actually reacted to make a product. Now, what can affect the rate of a reaction are three things. They could be the temperature, the concentration, and the pressure if it's a gas reaction. So what we're going to be looking at is when we have successful collisions, when we change temperatures, concentrations, and pressures. What happens when we heat up a chemical? Now, when we heat up a chemical, the chemical is able to move at a various speed. Now, if we've got solid particles here, these particles are able to vibrate on the spot, so they're able to move. Now, as we heat them, they're able to move quite a bit more. In fact, they might even be able to move away and around from each other. So we're able to get this movement when we have these particles, or when we have them at higher temperatures. So when we have particles at higher temperatures, we can see here at the low temperature these particles are hardly moving. Now, when the particles collide, there is a chance there'll be a successful collision. Now, when they're moving slowly, there is less probability or less chance of a collision. Whereas on this side, where we've got them heated up and you can see their movement is a bit quicker, then there is more chance of a collision and therefore more chance of a successful collision. So changing the temperature by increasing it can increase the rate. So increasing the temperature increases the rate. Now, when we have a concentration, we can have a significant difference in concentration. So if we had a look here, we've got a concentration on the one side and we have a concentration on the other. Now we can see on this side here there are more particles and therefore it has a higher concentration, whereas on this side there are fewer particles and therefore a lower concentration. Now, how does that affect the rate? Now, if we have a look here where we've got two reactions, one with a very low concentration and one with a very high concentration, then there is likely to be more successful collisions in this higher concentration than there is in the lower concentration. So, increasing the concentration will increase the rate. Increasing the concentration increases the rate of the reaction, so more successful collisions. Now, how does pressure affect the rate of a reaction? Now, if we have a whole load of particles here, now these particles are quite spread out, so they have a low pressure. Now, if we were to take these particles and then put them under pressure, what would happen is that we would start to move these particles into a smaller area. So now they're in a smaller area, they're under higher pressure. Now they're in a higher pressure, they're closer together, so now they've got more chance of a successful collision. So if we have a look here, we've got the low pressure, so the particles are quite well spread out. They can collide, but if we increase the pressure and put it at high pressure, they're closer together, so more chance of collisions. So if we increase the pressure, we can increase the rate. So increasing the pressure increases the rate. Okay, so with collision theory, we've touched on this quite a bit. Now, if we are looking at the temperature of the reaction, okay, what we're doing is we're increasing the kinetic energy of the particles. So they move faster, there is a greater chance of having more collisions per second. And that's key to how we can actually monitor the rate. So when they collide, they have more energy, so there will be more successful collisions. Again, we're increasing the number of particles in the same space, so the particles are much more crowded, so therefore we're going to have more collisions per second. And the last one is if we increase the pressure in a similar way to the concentration with the gas reactions, okay, we're going to get more collisions per second. Okay, so the idea of collision theory is that we have more frequent, more successful collisions, and to put that into a better term, it's more collisions per second. Now what we can do is once we've carried out some experiments, we can analyse the data that we get. Now along the y-axis we will plot time because we will have been timing the reaction. Now on the y-axis we can have either the amount of product produced or we can have the amount of reactant used. Now I'm just going to focus on neither of these, to be honest. I'm going to get rid of them so we can actually see the shape of the graph. Now we're going to look first of all at a reaction done at a high temperature. Okay, now the shape of the graph will look like this. Okay, now this means, as we've seen before, we start off fast and then as the reaction goes on it gets slower until we get to a flat point where the reaction has stopped. Now if we were to repeat that at a lower temperature, we can see that the graph is less steep at the beginning, but it still curves and we still get slower as we go along. Now the key thing to think about here is when does the reaction finish. Now if we look at the red one, if we go from about here, that is the time when the reaction finishes, whereas if we look at the blue one, we can go down to here and we can see that the reaction has finished there. So we can see that because the red one finishes earlier, we get a faster reaction time. But you'll also notice that they both produce the same amount of product or reactant that has been reacted. Okay, so that's the end of our second rates of reaction lesson. So we have summarised what we've done. We've looked at the collision theory, and a key thing is to remember frequent successful collisions gives us an idea about rate, because you can collide and not be successful. I always think about an analogy of a nightclub, that if you're there the more boys there are, the more girls there are, depending on what you prefer, the more chance you have of getting a snog off one of them. So in terms of concentration, the higher the concentration of boys and girls, the more chance you have of getting a snog. And I think this works quite well with this idea. Now, it means that you don't just chat them up, you actually have to get the snog to get that successful collision. Now, we've looked at how pressure, temperature and concentration can affect the rate. So an increase in temperature, an increase in concentration and an increase in pressure will increase the rate of reaction. And then we've looked at analysing some data and pointing out where the fast parts of the reaction are, where the slow parts are, and comparing two sets of data on that. Anyway, I hope you enjoyed this, and I will see you next time. Bye-bye.